Hello everyone. We are now going to see band reject filter using multisim here. So I am Professor Suni Mankari from Electronics and Communication Department of Guru Nanak Dev Engineering College, Bidar. So we'll be now demonstrating and we'll be now starting the band reject filter using multisim. Right, so you have to take out you have to be in the multisim software. You have to download it, you have to install it. After that we are going to the after installing and all, you'll be getting this type of screen there. So in order to go for new file, in order to create new file, you need to go to this design. Yes, you can click here. This is, you can again clear sub you can again create subfolders in this particular. You can rename this file, right? You can rename this file and you can save the files here. Also you can save it in the form of sub files under design 1. You can also rename it and put other files into that. So here you can see from the screen that there are so many different options given to you. So let us first be compatible with our tools whatever present in our multisim software, then we'll be going to the actual experimentation and all. So first we'll go with the file. So in file you can create new file, open samples, close all, save as, save all, projects, packing, printing options, recent designs, recent projects, file information and exit. So these are the what do you say, different things or different operations that you're going to perform using file. Next comes your edit option. You can basically use this one for editing and all, cutting, pasting special, selecting, graphic, annotation, order, all these things, right? So next we'll go to the view button or the view option there. In view option you can go for full screen, parent sheet, zoom in. Basically we are using it this particular option for zooming in and zooming out. You can adjust the zoom area and all. You can also fit into page. So all these things have been done here. Next comes your place. That is very important for you. That is the in place option. You will be having components. Through components option you can, this is the master database having both corporate and user database, okay? So it is having the combination of all. Next you can these are nothing but the groups here: sources, basics, diodes. Basics, in basics you'll be getting LEDs, resistors, capacitors, inductors, yes, potentiometers with different values. Example, just I'll show you here. The resistor is there, right? Simple resistor. If I, you can put there. You can also change the value of your resistor. Similarly capacitor. Simply if I am having a capacitor of 1 farad, see, so this is the option. So for resistors you can see there are number of options there. If anyone you want, you can just click on that and you can use that resistor. Suppose I want to use 1 kilo ohm of resistor, so I can put 1k here. Then I'll be getting enter, I'll be getting 1 resistor. This I can use there, right? In this way you can select that particular capacitor. If I want 1 microfarad of capacitor, or simply 1 micro 1 farad of capacitor. This is, sorry, 1 second. Yes, you can see, suppose I want 1 picofarad of capacitor, that is being selected, and if I click OK, then it will be available here. So wherever I want I can put that there, right? In this way I can choose my components and place on my screen there, right? You can also use so many other components. This is only in the basic one. You can also use it in diode, transistors. There are so many options there. So depending upon which type of experiment you are doing and what are the values there, that you can just select and place them. Next comes your again how to connect. There are so many components, different components here. Yes, I want to just connect that, so I can connect using wires. So I can take a wire, just drag it and connect it. Just click enter after dragging. Again, you can just see, again I'm dragging it. I'm clicking enter again. From there I am clicking again enter. In this way you can join the different components, resistors, capacitors using this line. Again, for junctions you can use the junction there, right? You can use junction anywhere. If there are two or more components that you are using, then you can use junction there. Similarly, bus for connecting and all, for connectors and other. If you are using multi-page, suppose if you're performing some of the experiments may be having 2 to 3 pages, then you can use the option of multi-page. So that is not so important for you. The main important option for you is your place. In that, component junction wires is that you will be going to use most frequently or more frequently compared to other options. Next comes your MCU, that is for debugging and all. Next comes one more important is your simulate option, basically to run your program or run your whatever the circuit that is being what do you say, placed or rigged up in the multisim. For that purpose here, if you're running the option, if you're clicking on the run option, then it will start simulating your program, right? In that, we'll again, you're having different instruments. The instruments are also placed on the right hand side. You can see here this particular instrument. This is your multimeter, this is your function generator, watt meter. You can directly take from the screen, or you can go to your simulate button. From there, if you're again, you can choose the instruments button and you can just select that particular instrument. Next comes your transfer. Basically, we are not using here for multi-board and all, you're using this transfer tools. Sorry, tools. In tools you are using variant manager, database, component visit. Again, you can use different tools in this particular software here. Reports options, these are also present there. So let us start here. So in this way, whatever I have shown you as an example here, in this way you can just select a component. You can just select a component there. You can place it. After that, after placing it, you can connect it using wires, right? So here we are now seeing regarding the band reject filter, right? So in band reject filter, before going to that particular this thing, here your band reject filter is nothing but you're connecting two filters, that is your high pass filter and low pass filter, in parallel with each other. Then you're adding a summer circuit or a adder circuit to it. So we'll just go to that. Sorry. Yes. So this is the, what do you say, this is your rigging up of the circuit, placing of band reject filter. Here you can see that it is a, here you can see that it is a, here you can see that it is a combination of high pass filter. So here you can see that it is a high pass filter and a low pass filter there, right? So you can see that there is a function generator here. To that function generator, a high pass filter and a low pass filter is connected. You can see that we are connecting a high pass filter and low pass filter in parallel with each other. Then again we are adding a summer circuit or a adder circuit at the end here. To my summer circuit, I am again adding an oscilloscope. So let us first see what is the main function, or what is the main proper function of your band reject filter. Which filter is called as band reject filter? A filter who is who rejects a certain band of frequencies, that we are calling it as band reject filter. Here it is as we know that it is a combination of high pass filter and low pass filter, right? For low pass filter, the highest frequency we are taking into consideration, and for high pass filter we are taking the lowest frequency into consideration. So whatever the difference between the high pass frequency and the low pass frequency, that we are calling it, in that particular range your band rejection will take place. Basically your band reject filter is nothing but it is having the frequency response as first it is a pass band, then it is a stop band, then again it is a pass band filter, right? So it is nothing but in the stop band, here in the stop band, so whatever the frequencies are present, they are rejected or they are attenuated or they are eliminated, hence it is also called as attenuation filter or elimination filter. Because in that particular band of frequencies in stop band, the what do you say, frequency or the amplitude of your signal will be reduced or will be eliminated or it will be attenuated, hence we are calling it as hence we are calling that band as stop band. And because of presence of stop band in two pass bands, we are calling that filter as elimination filter or attenuation filter, right? So here we, if you see the components, if there is a function generator present, there is a function generator present. Next, if you see, this is nothing but a function generator. Your first we'll see the high pass filter. You're taking a 741 op amp, you're taking 3 op amps here for high pass one, for low pass second, and for adder third. You can see your high pass filter having combination of resistance and capacitance, right? You already know that your filter basically is made up of RC components, that is your resistor and capacitor components. Depending upon the frequency of attenuation, and depending upon the FH, FL, high frequency, low frequency, your RNC have been totally dependent upon, or simply you can see your frequency is totally dependent upon the chosen values of RNC. How you are choosing your RNC, your frequency will also change regarding that, because F is equal to 1 by 2 pi RC. That is the formula here. So here we are taking, in the high pass filter, we are taking capacitance of 20 microfarad and resistance of 420 ohm. Again we are placing the positive plus VCC to the seventh terminal or the seventh pin of my 741 op amp, and to 4 terminal I am giving negative supply, that is -5. If I am using +5 there, then I need to use -5 my VEE. Next here you can see that your second terminal, it is again given back to the output, that is output number 6 there. So this is regarding your high pass filter. Again it is connected in cascade with a resistor of 1 kilo ohm. Now we'll be moving on to second filter, that is your low pass filter. In low pass filter you can be seeing that you are able to see that again we are using the combination of resistor and component, resistor and capacitor. You can see that the input is common to both of them. For whom? For my high pass and my low pass. A function generator's input is, I am giving this function generator input, the positive of my function generator input I am giving it to first circuit, that is high pass circuit, as well as the low pass circuit here, right? So here only the thing is your R and C are been replaced. The only difference between high pass and low pass is your R and C have been replaced. So you can see here the resistance value for my low pass filter is 2 kilo ohm and the capacitance value is the 50 microfarad. Again you are connecting VCC plus value to the seventh pin of op amp, and for fourth pin of op amp I am connecting -5 VEE. So here again I'm giving a feedback there from 2 to 6. I'm shorting that. Again to that particular circuit, again one more resistor is being connected, that is of 1 kilo ohm. So from the resistances 1 kilo ohm, that is R2 and R4, both are connected to the, both are shorted there. From there again it is going to the adder circuit or the summer circuit that is present at the last. Again you are giving this plus VCC and minus VE there. Again in feedback you are giving this R5. You can see that your plus terminal is being grounded here, and your minus terminal, it is being given as with feedback resistor, it is given back to 6th pin of my 741 IC. So after that it is being connected to CRO. This is nothing but your CRO. So from CRO you can see that the input terminal, whatever the input I am giving to my filters, that is high pass and low pass, from there only I am taking that input and giving back to my CRO, that is channel number 1, that is channel A. And next second pin I am grounding. So same thing, channel B, you can see I am connecting the output of my band reject filter, that I am giving it to channel B, and one more terminal I am just grounding there. So this is the rigging up of my band reject filter. You can just see, just to see as an example here. In this way you can delete it. So here we are taking 3 watt 741 op amps here. If you just don't know that component, you can just give 741 there, or simply you can write op amp there. So here you can see, so I am using the standardized one, that is 741 op amp. I am choosing that one, I am clicking OK. So here I can place my op amp. Again I require one more op amp. Again I am taking this particular op amp. Again I am taking one more op amp. Placing. This is my function generator. Sorry, this is my multimeter. I don't want this multimeter, right? So in this way I am selecting my operational amplifiers. Next I am choosing the sources here, voltage sources. So you need to select this VCC. Okay. So I require this VCC here. Again I require it here. Again I require it here. Alright. Similarly I want to take now VE. Again I need to take that. I want it here. I want it again here. Again I want it here. Right. So I have taken VCC. I have taken VE. Now I need to select my components, that is resistors and capacitors. Again I will go to select all groups, then I'll go to basics. There I can choose resistor. If I want to have 1 kilo ohm resistor, then I can use here. So in this way I can just place my components here. Again I need to select my capacitors. So capacitor I'm going to select here. Let us select 1 nanofarad of capacitor. Next I can change it. I'll show you how to change it. Again I require here. That's all. I require only 2 capacitors here. Then I also require a function generator that I need to place here. Next I require a ground terminal. Place component, then or simply a ground is present here. So you can use ground there. Select. Here I require a ground. One more. Here I require a ground there. And no, here I don't require that ground. So in this way you can just place the components. Now in order to rig up the circuit, or in order to interconnect them with each other, I again need to take a wire there and I need to connect it. First let us see the circuit diagram. Your R1 is in this format, so you need to rotate it. Just rotate clockwise. So using wires I can connect this to this. After, in this way I can just next. So from function generator I am taking the input from function generator. I am giving it to my capacitor C1. Again from there only I am taking it. I need to add a junction there, here. From there again I am taking it to the next level. That will do it out later. I am connecting my 7 to plus VCC and 4. So this I need to again rotate it. Again I need to just rotate it so that easily I can connect it to that. So this has been connected here. So in this way you can connect to this one. So again I'm going to connect this to, yes. So in this way, or again I require a ground here that is connected here. Yes. So in this way you are going to rig up the whole circuitry. In the similar fashion you are going to rig up the whole circuitry. So this is the example for, in this way I have connected or I have rigged up the circuit just as shown below. We have done this particular part, other part we have not done. So you can do in the similar way. Again I need to, I'll just show you how to place the CRO there. There are so many options here. From there you can see multimeter, function generator, watt meter, oscilloscope. You need to connect here. Right? You can just take it and just select it, put it on the screen. So this is the actual circuit design of your band reject filter that I have already done. So we have seen the connections regarding high pass filter in the similar fashion. You need to connect it for low pass, and then you're giving it that to add the circuitry. You can see that your channel A is nothing but the input one. Yeah, you're taking it from the function generator, positive of the function generator. Next, your the channel B is nothing but the output of your circuit, that is the actual output. Let us now run our circuit and see what is the result here. Go for simulate run. Before doing that, you just need to select the function generator. I am keeping the value of 1 hertz there. The frequency of my input signal, because I'm using a function generator, you can see from the symbol that you can use 3 types of symbol signals there: triangular, sinusoidal, and square wave. So I am choosing the sinusoidal one. The amplitude of that particular, you're having the options here, so you can just change it. So I am keeping the amplitude of my wave, of my input wave, as 1 volts peak to peak. From positive peak to negative peak, it is of 1 volts amplitude, and the frequency I am setting it as 1 hertz. So now I need to go to the simulate, then run. I need to check at my output. You can see that your channel 1, or your first channel that I have put at 50 millivolts, and channel B also 50 millivolts, both on DC, and time base you can just vary, right? 1 second or 50 millisecond or 200 millisecond, and you can observe both output and input both here, right? So this is your output and input both here. Also you can change the frequency. If I'm using kilohertz, then it will be very high, so I'll just go to hertz. If you want to go for stop simulating, then I will go to this. Again, if I want to change the values for this, I can just change 3 hertz, 4 hertz. So you can see that this is the value of input and output here. So here, for a certain set of frequencies, or for a certain band of frequencies, what happens is the amplitude of your, basically, your the band in band reject filter, it will reject a certain band of frequencies given to it. It will only allow the pass band to pass through it, especially from 0 to FH and above FL. These frequencies it will allow, but the frequencies between FH and FL, it will not allow, or it will just attenuate it, or it will just eliminate it. In most of the cases, it will attenuate it. So this is your output regarding your input here. You can see that I can also change the frequency here. For 5 kilohertz, it is again changing both my input and output. You can also change the time base here. So if you're taking out the frequency response, if you're taking out the frequency response of band reject filter, from there only you can like easily understand that frequency response is nothing but the graph between voltage gain and frequency applied. So whatever the frequency you're applying to the circuit, that is taken on the x-axis, and the voltage gain, that is output voltage divided by input voltage, that I am applying at the y-axis. If I plot the graph of frequency and gain, then I'll be getting the frequency response. From frequency response only you can easily get the value of your stop band, or you can easily get the frequencies for stop band. In this particular experiment, we have taken the values of here we have taken the values of 420 and 420 ohm and 20 microfarad. So first I need to calculate the high pass filter, that is fh is equal to 1 by 2 pi rc. If I put the values of r and c in the equation, I'll be getting the value of 1.95 hertz. That is nothing but my high pass frequency. That is, sorry, it is not high pass frequency. Yes, it is. If I'm substituting the value of 420 ohm and 20 microfarad in the formula 1 by 2 pi rc, then I'll be getting the high frequency, that is fh. Next, from low pass filter, I am getting the frequency FL, that is again I am using the same formula 1 by 2 pi RC. Again the values of R and C are changed in the low pass filters. So after calculating, I will be getting 1.95 hertz, and here I will be getting 18.96 hertz. So here so this is the value of FL in high pass and FH in the low pass here. So the frequency response of my high pass and low pass, both I'm adding, and I'm giving it to the summer or add a circuit there. It will just add the frequency responses, and it will give the pass band, stop band, and then it will go for the pass band. So in this way you can calculate the band rejection of your frequencies. Thank you.